Hello, students. Had a couple questions pop in out of 4-3. And 4-3 had, let's see here, question 5D. So let's see here, 5 part D. So yeah, finding the LCM for each of these two numbers. Yeah, I think personally for numbers this big, especially when they're that raised to a big exponent, I would do just the prime factorization method. I think that's going to be your best bet. And once you do prime factorization, everything else should be kind of falling into place. So find the LCM using any method. So you do have a choice. You could do it many other ways. I can't think of another way that would be any good at all, but perhaps one of you can think of one. So we're looking at part D. So yeah, when you see 8 to the 100, I would rewrite that as 2 cubed. Like I'd factor 8 down into 2 times 2 times 2, pull that one out to the 100, making it 2 to the 300. Okay, and then do the same for 50, right? So what would 50 to the 100 be? Well, 50 is what? 2 times 25, and 25 is 5 times 5. So this would be 2 times 5 squared to the 100, which would be 2 to the 100, 5 to the 200. And then do exactly what we did in class with prime factorizations. If you want the LCM of 8 to the 100 and 50 to the 100, well, then you would want to use the larger of the exponents to make it happen. Okay, if you want the GCD, you would choose the smaller of the exponents. Okay, so totally legitimate approach there. Let's see here. Let's clear all of these off. And number 9. Number 9. Let's see here, number 9. So yeah, least common multiple. Will that ever divide the GCD? Will it ever? So will a multiple ever divide a divisor? So it's probably good. I mean, if you're just kind of thinking about it here, remember what is a multiple? So if I was thinking about multiples of 6, right, that would be 6, 12, 18, 24, 30, and so on. But divisors, those are multiples of 6. Here's divisors of 6. 1, 2, 3, and 6. So it is possible to have something show up as a multiple and a divisor, but the only real chance you have of that is when you choose the number itself, right? So is it possible? That is certainly possible. But again, now we're talking about two numbers, and it does say they have to be distinct natural numbers. So if they are distinct, that means they're not the same number. Then the GCD, will have to be something that divides both of them, but it has to divide the smaller one. So it has to be less than or equal to the smaller number. So if you just say, okay, so I know A is less than B or less than or equal to, well, it can't be equal in this case, as I said, they're distinct. So A has to be less than B. Then the GCD of A and B, well, it has to be less than or equal to A. And if you just say that A is the smaller one, it has to be less than or equal to A. Okay. And then the LCM, well, the LCM of A and B, it actually has to be greater than or equal to each of the numbers. Okay. And so again, A is the smaller number. Well, it has to be greater than equal to A. It also has to be greater than equal to B. And B is actually bigger in this case. So I'd probably do that one since that would push the number out just a little bit further. Okay. So yeah, but it is true that it has to be greater than or equal to A. And this one has to be less than or equal to A, and it has to be less than or equal to B. I just put in one extra condition that I think would be kind of helpful there. So there you go. That would be kind of the big piece there as to why it does or does not work. Don't forget for part B, if you remember what we did in class, the GCD times the LCM of two numbers is equal to the product of the two numbers. So does the LCM divide AB? Well, The only time it would divide is if the LCM is a multiple being multiplied by something to get you to A times B. And I think we can see that that definitely does happen here. Okay. Those are probably good. Whenever you see true, false, again, put that in your head and be like, hey, I bet those are going to be always, sometimes, never questions on the test. And you'll probably be in pretty good shape. Let's see here. We've got for 15, 19. Let's see here. So 15. Light display has three colored lights. They flash for an instant at regular intervals. The yellow one is 15 times per minute. Okay. 15 times per minute. So I think the only piece to kind of make sure of here is just making sure if it's 15 times per minute and a minute is 60 seconds and it's 15 times per minute, we're talking about every 4 seconds. So this one's every 4 seconds. The one that flashes 6 times per minute would be every 10 seconds. And the one that flashes 12 times per minute, you have to divide that in, would be every 5 seconds. So you want to say, how much longer must you wait? Make sure we're talking about kind of finding when will these all line up again. So the 4-second one, it would line up on 4 seconds, 8 seconds, 12, 16, and so on. 10 seconds would be 10 seconds, 20 seconds, 30 seconds, dot, dot, dot. And 5 seconds, of course, is 5, 10, 15, 20, and so on. You're trying to find when do those match up again. Big hint, sounds like some kind of common multiple is what we should be looking for there. Okay. What else do I have? I think they said 19. By selling cookies at 24 cents each, they made enough money to buy several cans of pop costing 45 cents each. If there was no money left over, what is the smallest number of cookies he could have had to sold? So this is going to be a good one because it'll be a ratio. There might be multiple answers here. So again, by selling cookies at 24 cents each, we don't know how many. So we'll just say 24 times n. That's how much money I brought in. Now I made enough money to buy several cans of pop costing 45 cents per can. Well, I don't know how many of those I have either, right? Is equal to 45 times K. All right. So let's see here. We need these to be, so some multiple of 24 has to equal some multiple of 45. And again, I just love prime factorization once you realize it is the DNA of the numbers. I think you'll probably be in pretty good shape too. So 24 is 8 times 3. So that's 2 cubed times 3, still times n. And then over here I have a 45. 45 is a 9. 9 times 5 is 45. So 3 squared times 5 times K. And so again, we're just going to try to figure out when those match up. So n is going to have to bring another 3 into play because there's already 2 3s on the right-hand side. I need to bring at least one more 3. So n has to have a 3 in it. 3 to the first, that gives me 3 squared. There's already a 2 cubed. There's no 2 cubes over here, so the 2 cubes must be hidden inside of K. And then I need a 5 as well. So 3 to the first times 5. So that's kind of telling you what you would need here. So you'd need 15, 15 cookies to be sold. So times 15. And on the other side, you have a 3 squared, so that's done. You have a 5, so that's done. The only thing you're missing is a 2, and you need a 2 cubed. So that tells you how many cans of soda. So there'd be 8 of these, and there'd be 15 of those. And you can check it, right? 15 times 24. Let me open up a new tab. Let's see here. Desmos. What do I want to do? 15 times 24 cents is 600. Okay, and 45 times 8. I think that's what I said. Oops, I got my numbers backwards a little bit there. Where was it here? Yeah, I would need 8 more of those to get 8 times 45. That should match up. Yeah, I'm missing a 3 there. Oh, 24 times 15. What did I put in? I put in 25. So it should be 360, and 45 times 8 is 360. So there we go. I just typed it in. I put in 25. All right, so there you go. Yeah, that tells you how many 24-cent items you need and how many 45-cent items you need until they match up again. So there you go. It takes care of those two. Let's clear these off. All right, let's double check. Let's see here. That's it for those. And math connections. Let's see here. 14 and 16. So let's jump over there. Math connections. Oops. Gonna have to jump forward. "14. A student claims the greatest common divisor of 0 and 0 does not exist. Is the student correct?" Well, got to go back to what the GCD means, right? So the GCD of 12 and 8 is 4. Why? Because 4 divides 12 and 4 divides 8, and there is no number larger than that that divides both of these numbers. So if you're trying to find a number, we'll call it D. So let's just say the GCD of 0 and 0 is D. Then D has to divide 0, that first 0. I'll change color for the second one. I'll put a big red right there. And we know D has to divide 0, the second one. And so you have to think, what number could it be? As long as it's not 0, we had an issue with 0 dividing 0. So could I say the GCD is 1? Well, let's see here. 1 does divide each of those. So yeah, it sounds like the GCD could be 1, but then I could choose 2, right? And 2 divides both of those numbers. So what about 3? 3 divides both of those numbers. So the question is, how would you find that GCD if basically outside of 0, it seems like every number works. So I'm going to let you figure out kind of how you would respond to the student there, but hopefully I gave you a nudge in the right direction. That was 14 and 16, I think was the other one. I don't know if I want to give this one entirely away, but I will give a little nudge in the right direction. When in doubt, write it out. And I would go with, instead of between 1 and 10,000, why don't we just do like between 1 and 100? And instead of multiples of 3 or multiples of 5, I'm going to do multiples of 4 or multiples of 7. Making some numbers up here, okay? So if you're thinking about it, the multiples of 4, and then the number is inclusive, so it would include 1 and include 100. So the number 4, think about all the multiples of 4. Well, 4, 8, 16. Oh, I don't know why I didn't say 12. We'll say 12 and then 16 and then 20 and then dot, dot, dot all the way up to 100. Well, this is an arithmetic sequence. From chapter 1, we know how to find how many terms there are in that. And then 7, we can do the same thing. 7, 14, 21, dot, 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 all the way up. In this case, the 7s, where did they stop? 98. Okay, and again, we can tell how many numbers there are in here. If you have forgotten a little bit, just remember we can line them up with something we can do. These are all multiples of 4, so you divide everything by 4, and you get a sequence that looks like 1, 2, 3, 4, 5, all the way up to 20. And down here, we kind of divide by 7. We get 1, 2, 3, all the way out to, let's see here, 10 and 28, so 14. There we go. Okay, so now what we're thinking of is here's all the multiples of 4. Here's all the multiples of 7. Just remember, when you are kind of creating this beautiful picture, think of it like a Venn diagram. Your multiples of 4 on one side, your multiples of 7 on the other. Multiples of 4, that is 4, 8, 12, 16, right? 20, 24. Then I'd say 28. But remember now, 28 is actually in both because it is a multiple of 4 and a multiple of 7. On the other side, I would be doing 7, 14, 21, then 20. And I don't know why did I write 20, 28. I said 28, but I wrote 24. Then 28. Then over here, I'd have 35, 42, 49, and then 56. But 56 would be something they have in common. And the same is true over here. 24, I'd say 28, then 32, 36, 40, 44, 48, 56. I missed a 52, 52, 56. And so 56, it has to be in that middle because it's kind of shared. So it's tempting to think that I would take the number of things that was in the multiples of 4 and add the number of things in the multiples of 7. Just remember, just like back in chapter 2, right? We can't just add those together because we will be double counting. That's why we did that activity with those images, with those pictures, with the attribute pieces. So make sure that at the end you remove the number of things that are multiples of both of those, which would be multiples of 28. And that's how you can go through and do that pretty quickly. So there's 20 multiples of 4 out to 100, plus, and there's 98. Oops, but that'd be only 14. Plus 14 of those. And then I have to see how many of these multiples are doubled up because they're counted twice. I have 28, 56. The next one would be 76. That's adding the 20. And then add another 8. So 76 would be 84. 84. So it looks like there's only going to be 3 of them going up to 100. So minus 3. So my end result would be 34, will be 31. So if I was looking for just page numbers in a 100-page book, that's what I would be. That's what I'd be doing there. All right. Well, that takes care of that. Thank you so much for the messages. I will see you shortly in class and have a great rest of your day. Off you go.